Hello, hi everybody. Welcome to this week's meeting. So before we start, a little disclaimer. The meeting happened a couple days ago, and I totally forgot to hit recording. So I'm basically recording this meeting now. It's only myself, so I'll be walking through the meeting. I'll be walking through the slides. I'll be walking through the Kaggle notebook that I did for this week. And then I'll close with the next week's meeting. And yeah, so let's get started. Okay, so this week it was, well, before starting, some reminders. So if you have not yet, please join the Google group and then also join the Outlook group. This week's going to be all about EDA and Kaggle competitions. And yeah, we had some Kaggle presentations, but because I forgot to record, it's only going to be me today. And then next meeting is going to be about Clay and literature review. And I'll be talking more about that later. So let's get started. So one of the things that was the deliverable for this week was to do the readings on EDA. So basically, EDA really, really important for machine learning competitions, as you will see, but not only machine learning competitions, but the research as well. So EDA is all about understanding the data deeply and exploring the data. So probably one of the most overlooked things that happen when we start doing research is not doing a lot or not doing enough exploratory data analysis and basically just visualizing distributions, relationships between variables, seeing if there's any outliers, the types of data that you have, and maybe identifying missing values and inconsistencies in your data. So one of the things that I really like doing is converting the data into embeddings and doing some kind of dimensionality reduction on those embeddings by using algorithms like t-SNE or PacMap or UMap, and then visualizing the embeddings and seeing if they form any kind of clusters or if any patterns emerge from that. Because at least when we're doing research, most of the data is unstructured, mainly images and text. So doing that, basically trying to represent that data into a vector space and visualize that, you'll be able to kind of see some patterns that arise from that. So something that I'm actually going to be doing that in the notebook later. So basically, some common EDA techniques. So you can start with univariate analysis of the variables. So basically, you just analyzing one variable at a time. And then you can utilize many visualization techniques. Matplotlib and Seaborn have many types of visualization techniques that you can do. And then also perform bivariate analysis of variable pairs. So you just basically compare correlations between two variables in your data set. And then you can also do a multivariate relationships of all of the features, maybe doing something like a correlation matrix that you can see how all of the features are correlated to all of the other features. So just some techniques. I hope that the reading of the week goes much more in depth into the EDA techniques, but the focus of the meeting today was actually about the Kaggle competition. So this is just a recap of the reading. So next, those were the people that presented this week. Unfortunately, because I did not record the meeting, it's only going to be me today talking about the notebook that I did and the competition that I participated. But yeah, we had more people presenting. So if you're interested in seeing their presentations and what they came up with, please check the Google Drive. I'm actually going to share this right now. So if you go on the SGT Drive, there's going to be, and let me make my screen bigger. There's going to be a shared folder, and then there's each week there's going to be a folder for whatever people have done in that week. So for the EDA Kaggle competitions, the work's going to be here. For example, they're choosing a venue. People who did slides, they were able to add their slides here in this folder. So just so you know, if you ended up doing contributing and you do not present during the meetings, you're still more than welcome. I would say you were very much encouraged to share the things that you have done in the drive, and yeah, just basically using the drive as a place for putting all of the contents that you have done. So, okay, so those are the people that presented. Without much further ado, I'll go into my presentation, or at least my competition that I participated. So basically, I participated in this fake or real competition on Kaggle. And this competition is mainly about trying to identify human text versus LLM generated text. So and I'll be sharing the notebook as well. But there's basically one column in the data set. It's text that was generated by human beings, and then the other column is basically using an LLM to change that text in some way. So as you can see here, both text in each sample, the fake and the real, have been significantly modified using LLMs. So the task is to find which text in each pair is considered the real one. And then they provide a lot of information about the competition. One really cool thing about the competition itself, I think discussion. Yeah, this competition was actually accepted at IEEE for the SAT workshop. And if we click here, it's basically this workshop here at IEEE. And I believe this conference is going to be held in Munich, in Germany, in March of next year. So the competition is still going, and you can even check the leaderboard. And the best performing model right now, at least on the publicly leaderboard, is almost 97% accuracy, or the score that they chose for the competition. But that's mainly it. Is basically you have text and you're trying to identify which of the text is real. And there's only 6 days left in the competition. And there's also cash prizes. And then, oh, one thing that I did not mention is that the organizers, they're inviting the best performing models to write perhaps like a paper or something, and then they can go to the conference and present their findings, which is really cool. And also you can see that the competition is being held in conjunction with all of those organizations here, especially the European Space Agency, which is quite cool. So with that, I'll be sharing my notebook now. So this is the notebook that I've done. And this notebook was very inspired by this other notebook here. And let me show you guys actually. So when you go in the competition itself, one way of doing competitions or simply understanding things that have been done is to go on the code tab, and you can see basically notebooks that people have done and shared with everybody to check. And you can filter them by, for example, most votes. And you can see the ones that were the most voted notebooks. So I actually saw this notebook here, the fake real, using Light's GBM and the Berta model. And I thought it was really cool, and I wanted to basically replicate the results and perhaps even improve a little bit further. So everything, I believe this is Mandarin, I'm not sure. But yeah, so I basically took this notebook here and I kind of changed and made my own in a way. So let me, okay, so this is the one here. Then yeah, I do give credit saying that it was basically inspired by this Faker Rio notebook using LightGBM and the Berta. And the models are the Berta model. If you click here, it's going to open up this page here on Hugging Face, which is the page about the model. The Berta is a transformer model that improves on the BERT and Roberta. And you can even, check the paper that they have and read more about the model and what it does, and basically what it basically the improvements that they've made on top of regular BERT or Roberta. And I believe also if I go back, they also have they have the repo, like the official repo. So this model specifically was made by Microsoft, and it's a transformer model. So we'll be using that to train on the data. So, but before that, yeah, just walking through the notebook, and this is basically the presentations that we had during this week. It was people shared their screens and they were walking through their code and explaining what the composition was about and what they did to basically make a notebook solution for the competition, and then the results at the end. So here I'm just importing a bunch of libraries. This is just a configuration class. I am using CUDA, so if you don't know, Kaggle allows you up to 30 hours per week of GPU usage. And if you go here on settings, accelerator, you can select GPU, and yeah, you can train models using a GPU, which is really, really nice. So here I'm just loading the data. And as you can see, the training data, not many samples, 95 samples. And yeah, and then I do some augmentation, like basically swapping the text one and the text two columns for another 95 samples. So the first 95 have text one and text two, and then the bottom 95, the text two is under text one is under text two, and then I also flip the labels. So the label here zero means that the text one is the real sample, and the text two is the fake one. And then one meaning that the text two is the real sample, and text one is the fake one. And this is based on the real text ID that they use here. So basically, one means that the text one is the real one, and two means that the text two is the real one. But when we try to train models, basically using some kind of binary class is better than using like one or two. So here just showing you guys that, yeah, basically the first sample is basically the same as the 9/5 sample. It's just they're just swapped here. So the here on the text one, the Versa blah 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 is actually on the text two, and then the labels are also swapped, meaning that this one is the right one, and then this one is the real one. Then here we're doing some feature engineering using NLTK. And yeah, basically we're creating those columns, basically counting the number of characters in a sentence, counting the number of words in a sentence, counting how many sentences are in one sentence, the average word length, and then some flash reading ease scores and gunning fog and latching ratio features. And then another thing that the notebook did, the one that I got inspiration from. So basically I copy and pasted all of this code from that other notebook. And I'll tell you guys the things that I've done that is not on that notebook. But one thing that they have done was basically get the embeddings of the text and then basically do two extra features. One is to create a cosine similarity feature, and another one is a Euclidean distance feature, and basically add that as columns in the data frame. So we performed that feature engineering, and as you can see, we can get this data frame that has all of those features, and then here at the very end, we have the cosine similarity and Euclidean distance that ended up using the embeddings. But it doesn't use the embeddings itself, which was something that I thought it was interesting to try to explore, which I do later as like a next step or improvement. So first, we basically just get those features and then we train on them. And those are the feature columns. And then this is just the test features data frame. Here I'm just getting the embedding. So this is something that I've done. It's not included in the first notebook, but like I said, I like to get embeddings and try to visualize them to try to understand some of the patterns in the data. So here I'm just getting the embeddings of the text. And then I performed dimensionality reduction using TSD. And I'm only limiting to the first 95 rows because I don't want duplicates since we are swapping the the columns. And then here I'm just visualizing them. So you can see that it kind of forms some clusters, but the data is very much intertwined itself. And you can see the labels. The 0 label is blue and the 1 is orange. And then the text 1 column is the round circle. I mean, all circles are round, but it's the circle. And then the text 2 is the X. And then we go straight to model training. So first of all, I try to train a XGBoost classifier, and it's a binary classifier. Very easy to train, very fast. XGBoost does support GPU acceleration, so that's nice. It trains super fast. He ended up performing 84% of accuracy on the training data. And XGBoost actually outperformed the LightGBM because that's also something that I changed from the original notebook. The original notebook ended up using uh, LGBM, which means light gradient boosting machine. And it's a similar algorithm, uses boosting, but it's a little bit different than XGBoost. And XGBoost ended up being a little bit better. I think LGBM ended up being 81, and this one was XGBoost was 84. And then after that, we trained the Berta model, and it's basically the Siamese network. And you can go into it and see basically what it's doing. But we basically initiate this network model and then the data set, and then we do the training evaluation. We have the training data and the evaluation data, and then we basically train the model using PyTorch. So when I did that for the first time, just using the data set that we had, I ended up achieving this 95.78 accuracy here on that data. And then something that I did after was basically training on the embeddings data set that I'm gonna go up here and show you. So it was the data set, this one was the data set that I created with the embedding. So basically the only things that I used were the embedding vectors themselves. It was not the feature data or the features that we created. It was training only using the embeddings. And he actually performed, oops, I think I passed. He actually performed very similar. I mean, a little bit lower in the accuracy score. So this one, only using the embeddings, was 95.26% accuracy. So not bad at all by simply discarding all of the other features and only using the embeddings from the text. We're able to achieve basically the same accuracy, which basically indicated to me that I could probably try to improve that baseline model by trying to combine both approaches, which is something that I did. So I ended up doing a feature importance analysis, let's say, which is basically I train another XGBoost model on the training data without any validation set. So basically allowing the model to overfit on the data. And then I just wanted to know the feature importance. So like which of the features of the feature engineering step that we created were the most important ones. So basically I ended up choosing the sentence count ratio all the way to word count ratio features. And yeah, as you can see here, columns to keep. I keep all of those columns. I also generate the embeddings again, and I create this data frame that has the embeddings and it has the most important features. And then I train another deep model, and he ended up doing this time ended up doing 94.2 percent accuracy. When I trained the previous time, I ended up doing actually better. But after submitting to the competition, and I'll show you now. The second model actually ended up performing better. So if I go on submissions, the Berta model that I submitted that performed 95% accuracy on the training data, actually yield this 88.79 score. But the one that I trained on the final data frame, which is this one with the most important features and the embeddings, actually ended up performing a little bit better. So 90.66 um, score. And if we go to the leaderboard, that score placed me in 166. Okay. So I think yesterday I was in 109. So I dropped quite a bit today, which is it's okay. So I could simply keep trying. But I believe the first entry that I had, it ended up being like 200 or 300 place. So by simply improving, 2% in the submission itself, in the score, I was able to go quite high in the rankings. But yeah, as you can see, the competition is really fierce, and there's a big jump between even like the 10th place to the first place. So, but this is the public leaderboard, which is being evaluated on 45% of the test data, and the final results are going to be based on the other 55% of the data, and that's going to be in a private leaderboard that we don't see right now, but the organizers have access to that. So that's basically what I've done, and then I made a submission. This was like I put this together in a couple of days, so not too much work into it, but I already have ideas of how to improve this if I wanted to keep pursuing that. There's only like a week left of the competition, but it was a cool experience, and I learned a little bit. I had never used the Berta or even heard of the Berta before, so it was definitely nice to learn about this model and seeing how it performs. And then if I want to make like, I guess, another submission with this model, I can simply go here, or actually I need to save and submit, and then I'll just do like version 5 or whatever, and I click save, and then it runs, and then once it finishes running, I can make a submission to the competition. But that's basically it for the presentation. And basically what happened, I presented, and then all of the other people also presented during the meeting that was held on Monday. But because I'm here by myself today, that's all we have. So, which brings me to next week. So next week's deliverables are going to be, I asked the participants, you guys basically, to select two papers and to compare the methodology. So next week is going to be all about literature review and about clay. And basically one paper comes from clay, any clay lab or task that you are interested about. So you just pick one, and I'll show you how to pick a paper. And then you also going to pick a different paper from a different conference. So any conference that you like, any paper that you like, try to pick something that is similar, or is trying to solve the same problem, or it has a similar flavor. So, for example, don't try to pick an NLP paper from Clay and then a computer vision paper from a different conference, because the methodologies are going to be very different. And the reason for picking papers at different conferences is to see how they try to solve basically a similar problem with different approaches, and then also just increasing your knowledge of the approaches that are common on a particular task, like what people are using to solve a problem. And then I asked participants, they're going to be creating 3 to 5 slides. I think that is actually going to be 3 slides. So I'm actually going to change this right now. So it's going to be 3 slides, and they're going to be, I believe, 5 minute total or 3 minute total, depending how many participants we have. But I'll give more. Um, m- I'll basically make the thread post on Slack, and then in the post I'll have the steps exactly like what you should expect for the presentation next week. But that should be it. And then those are the people that actually agreed to or volunteer to present. So thank you very much for volunteering and for presenting in the following week. And then I guess coming back to this, also the reading. So we have a reading on literature review and we have the reading on clay. So make sure to do that. All of this information is going to be in the post. So one final thing, I mentioned that I was gonna teach you guys how to select papers from clay itself, and that's exactly what I'm gonna do. So there's this website that is the Clay 2024 working notes. I don't think they have the working notes website has not been published yet for the 2025 edition. So because he hasn't been published, we're just going to be using the 2024 edition for this, which is totally fine. You're still going to get some valuable knowledge from the methodologies that were used last year. So how do I find this website? You may be asking yourself. So if you just go to Google and you type Clay 2024 working notes, you should get this website here, which also I believe I included in the, I don't have in this slide here, but I have on the previous one, or I'm gonna have the link in the Slack thread that I'm gonna make. But basically, it's just this link right here. And here you can check every single lab from Clay. So all of the 14 labs in Clay. And let me actually show you. So if you go on Clay 2024, and I just go to the conference page in 2024. Here on the right, or here on the left side, we have like the a labs tab, and it has all of the labs that participated in the 2024 conference for Clay. So we have BioAsk, check that, Eloquent, eRisk, Exist, IDTP, and so on. And then Monster Clay was actually not done. So yeah, there is no Monster Clay lab, but all of the other labs, they they were done in Clay 2024 edition. So if you go to the working notes page, and you will be able to see all of the 14 labs and then all of the working notes that were published within the lab. So we have BioAsk, check that. And if we keep scrolling, Eloquent, eRisk, I'm gonna go to LiveClay because it's the one that I'm mostly involved with. So Image Clay, Joker, LiveClay. And then one cool thing, if you want to know more about a particular task within the lab, there are overview papers of the lab. So, for example, Life Clay has board clay, fungi clay, geolife clay, plant clay, and snake clay. So if I want to know more about plant clay or board clay, I can click on this overview paper and I can basically check. There's basically a paper that the organizers put together about explaining what the task is and just giving some introduction and some background of the task. So there's an introduction, there's a competition overview, and then they have some pictures here of the birds and the metrics, the time limits, the training data, test data, and the results and online write-up. So this is the best way to know or to get familiar with the competitions and the tasks available. And then the working note papers are actually down here. So for example, transfer learning with pseudo multi-board board call classification. So that was a paper that was done by Anthony, Adrian, and myself and Ashley. That was for last year. And then there's also our paper on snake clay. And then I think, yeah, the paper on plant clay. So if I click here, you'll be able to see the paper that we submitted for the conference last year. So that was the plant clay paper. So basically, your task for next week is going to be to select one paper, working note paper from clay. Here says 2025, but I'm going to do 2024 and one from any other conference that you like, and then compare their methodologies and basically create 3 slides for that. I'll give more instructions on what to expect in the Slack thread post itself. And again, those are the people that agreed to volunteer. And that was basically it. So that was the meeting that we had. I'll be sharing basically everything in the Slack post. So make sure to keep an eye out for that. And yeah, thank you very much for watching. And I hope to see you guys again in the next meeting. So thank you.